Okay, I guess we are live now. So two people are watching. Okay, let's see. So if somebody is in chat, can you guys just drop your name? I guess we are live now. So two people are watching. Okay. Okay, hi sir. Hi Priya, how are you? Okay. Okay, so today we are going to attempt a DPP of structure of atom. Okay, so I hope you have revised the concepts. Okay, we are going to attempt a total of 30 questions. Okay, and let me just tell you, if you want to join our WhatsApp channel, it's in the description. Okay, and every day we are going to come live near this time frame, 6 p.m. or 6:30 p.m. Okay, to attempt some DPPs. Shraddha, Ira, hi. Okay, 3 people have joined. Okay guys, now let's start the session. Let me just check the settings once and we are done. Right, okay. Now we can start the DPP. Okay, so let's go with our first question of the day. Okay, so this is our first question. Try to attempt it. I will set a timer of 1 minute for every question for you to attempt. Okay. So timer for this question has started. Now the question is, to give designation to an orbital, okay, we need to identify an orbital. I will go out of the frame. We need, so which numbers do we need? Principal and azimuthal, principal and magnetic, azimuthal and magnetic, principal, azimuthal and magnetic quantum number. Which one is the correct answer? You will get a time of 3 minutes. Try to answer. Priya, Shraddha, whoever has joined. Okay, hi sir, I am Inia. Okay, Inia. Okay guys, try to put the answers. Time is leading. 16, 15, 14, 13, 12, 11, 10, 7, 6, 5. Okay, we are done. I hope you guys have answered. Okay, 4 people have joined. So everybody who is joining, try to put the names. Okay, so now let's do this question. Okay, tell me, to give designation to an orbital we need, so which things we need to give designation to an orbital? So somebody has answered option number 3, Priya has answered option number 4, and option number 4 is the right answer. Let me tell you, we have 4 quantum numbers. Okay, the principal, okay, azimuthal quantum number, okay, and what, magnetic quantum number, and we have spin quantum number. Okay, now it tells us about the shell, okay, it tells us about the subshell, and this number tells us about what, magnetic quantum number tells us about what, it tells us about the orbital, or you can say orientation. Okay, orientation, got it? So these 3 things are necessary to tell about the orbital. Okay, for a particular orbital you need to know which shell, and then which subshell, and then which orbital. So we need all of these things: principal, azimuthal and magnetic quantum number. So for this question, Priya, you are right. Let's see who has answered. Okay, so question number 1, 4, Priya is right. Shraddha, you have chosen third. No, we just don't need azimuthal. If you have azimuthal and magnetic quantum number, but if you are missing principal, you will not know which subshell this orbital belongs to. Okay, so we need principal quantum number also. Got it? I hope you're done with this question, right? Now let's start the second question. Very good, Priya. By the way, Priya, you are actually continuous in class and it's very good. Okay, so okay, this is the question number 2. I'll not mark, I'll just set a timer. I'll start a timer. Okay, I'll start a timer of 1 minute. Okay, so 1 minute timing is there. Which of the following is not correctly washed? Okay, which of the following is not correctly washed? Tell me. Oh sorry, washed, matched. So energy associated with this, energy this, kinetic this. I'll remove this from here. Okay, out of these 4 options, which one is the answer? Let me just check your chats, guys. Priya, Shraddha, try to answer. Okay, there is a 30-second gap. Here I am seeing a time of 42 and here is 25. It means 15-14 seconds gap is there. So tell me, which one is the answer? Which of the following is not correctly matched? Okay. Okay, 8 seconds left. Try to do it quick. Priya, Shraddha, try to answer. Okay, so time's up, guys. Now, let's see the answer of this question. Okay. Which of the following is not correctly matched? We have to match the correct options. Okay. So first is energy associated with the Bohr's orbit is this thing. Okay. This is the energy associated. Now you must have learned minus 13.6 z square by n square, right? This is the energy. This is energy is in electron volt, and if you convert it into joules, okay, right, is not correctly matched. Okay, so everything will be correctly matched, right? So this is the energy. This is the formula for the energy in joules. Okay, got it, for a Bohr orbit. So option number 1 is, the statement is right, so it means option is incorrect. We have to find not correct. Okay, got it, not correct. Now second, energy gap between two orbit is this. Yes, the energy gap, if you take this on the other side, okay, E by Sc. Now you will see this will form as 1 by lambda, and 1 by lambda is equal to z square RH, rz square into 1 by n1 square by n2 square. You have read this formula, right? 1 by lambda is equal to rz square 1 by n1 square minus 1 by n2 square. I hope you have heard about this formula, right? So this formula is also right. So like the statement is correct, the option is not correct. Okay, energy gap between two orbits, got it. Now second, kinetic energy of the ejected electron is this. So h mu plus h mu naught plus half mv square. Okay, it means this is the work function. Okay, this is the work function required to eject the electron. Okay, got it. This is the amount of energy that you are putting. So if you rewrite this formula again, h mu minus h mu naught, okay, equal to half mv square. It means the energy that you gave and the energy that is required, if you subtract it, the energy that is left out will be given to the electron as a kinetic energy during photoelectric effect. Got it? So this option is also correct. It means obviously fourth will be the answer, right? Okay. Now fourth, energy of 1 mole of photon is equal to n naught h v by c. Now if you see 1 mole n naught, I think they are trying to represent the number of photons from here, right? But you can see it is not h v by c. The formula is wrong. It is sc by lambda, right? I hope you have heard. And if you multiply with number of photons, it is equal to n sc by lambda. This is the formula. Okay, and the formula is written wrong over here. Hence, this particular option is correct. So option number 4 is the correct answer for the option number 2. Okay, question number 2. So let's see who has answered. Priya, question number 2, option number 4, you are right. Shraddha, Aira, you have written option 2, which is incorrect. Okay, and Shraddha, try to write the question number dot the option. Okay, got it? You have to write with the options. Now let's go on to the next problem. Okay, let me start the timer. Which one of the following ion has the electronic configuration AR3D6? Which one of the following electronic configuration has so fine, which one of the following ion has the electronic configuration AR3D6? Okay, it should involve 3D6. And remember, the ions are charged, Ni3 positive, Mn3 positive, Fe3 positive, CO3 positive. So remove 3 electrons because all of these are 3 positively 3 charged. Okay. Atomic number are already given. Okay, so it's easy for you to do this question. Let's see. So Shraddha is telling question number 3, option number 4. Okay. Priya, I have not got your answer yet. Try to do it. Okay, I'll do it now. So let's mark the solution. Okay, So which one of the following ion has the electronic configuration Ar3d6? Remember, can you tell me the electronic configuration? Sir, 1s2, 2s2, 2p6, okay, 3s2, 3p6, okay, and 4010. Wait. 4s2, 3d10, sorry, okay. Now we have this electronic configuration. See, this is nickel, okay. What is the atomic number of nickel? It is 28, and subtract 3, how much it is? 25. Very good. Now Mn3 positive, Mn is 25 and 3 positive, it means 3 electrons are removed, so it is, how many electrons it has? 25 minus 3, it is 22. Got it? Fe3 positive, Fe3 positive is 26, okay, and we have to remove 2 electrons, so it is 23, right? Now cobalt is 27, and you remove 3, then you get 7, 6, 5, that is 24. Okay, now see, this is 25, 22, 23, 24, okay. So see, 2 electrons to 4, 6, 10 electrons, okay, will be covered in here. Now 3s2, 3p6, 18 electrons in here, okay. 4s2, 2 electrons, sorry, 8 and 2, total of 10 electrons in here, okay, and then rest of the electron will be in this orbital, okay. So electrons greater than 20 will be left in 3d10 orbital, okay. So how many electrons in here greater than 20? Because till 20 this will be filled, okay. After 20, so this is 5, this is 2, this is 3, this is 4, got it? Okay, wait. Just a second. Okay. 3d6. No, wait. Okay. Actually, cobalt is going to be the answer. Why? See, I'll tell you. Now, cobalt, what is the number? Atomic number is 27, right? Okay, so it means 27 electrons. If you subtract how many electrons? 3 electrons. You will be left with how? 7, 6, 5, 24. Okay, now 1s2, 2s2, 2p6, 1s2, 2s2, 2p6, okay, 3s2, 3p6, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Okay, now if you could see, till this point 18 electrons are filled, and till this point 3p6, okay, 4s2 is there and 3d10 is there, right? Now out of 24, how many electrons will be filled? See, it is left with 6 electrons extra after 18. This is 10, this is 8, okay, 10 and 8, and cobalt has 3 lesser, so it's 24, and when you subtract 24 from 10 plus 8, it means it is 6, okay. So 6 electron will be filled in this shell, okay, and not this. Understandable? 3d6. So Ar3d6. So Ar3d6 nearly cobalt 3 positive. Got it? So 6 will be the answer. Understandable? 3d6, because 6 electrons are left after this Ar. Understandable? Now let's see who has answered. Priya, okay. Shraddha, okay, good. Next question. The orientation, okay, it's Priya. Remove 2 electrons from the 4s and 1 from the 3d. Okay, good. We have to remove 1. Okay, somebody has answered, right? Priya has answered, remove 2 electrons from the 4s and 1 from the 3d. Yes, that's what we need to do. Because we have to remove 3 electrons and we need to choose which 3 electrons should be removed. Got it? And you have to remove 1 electron from the 4s, sorry, 2 electrons from the 4s and 1 electron from the 3d. Okay, timer. Let's start. I'll give a lesser time for this because I have already talked too much. Okay, the orientation of an atomic orbital is governed by. The orientation of an atomic orbital is governed by. So, which particular thing cares about the atomic orbital? Let's see who's giving this answer. Priya, Shraddha, try to answer. Priya, Shraddha, who's trying to answer? Okay, 23 seconds. 20 seconds are there only. See, I have already told you this particular answer. It's very easy. Let's do it. Okay. Fourth option number 3, Priya has answered. Anybody? Shraddha? Okay. Now let's start. See, obviously, I have told you principal quantum number will tell you what is the shell. Okay. Azimuthal quantum number will tell you what is the subshell. Okay. Then magnetic quantum number, okay, is going to tell you the orientation or the orbital, you can say. So third is the right option for this question. Okay, this was not a technical question, so it will not take you that much time. It should not take you that much time. Now let's go on to the next question. Okay, set a timer for this question. Okay, I should give you just this time. Okay, good. Now start the question. Let's see who has answered. Fourth, okay, fourth you have answered. Shraddha, you have answered option number 2, which is not correct. Try to check your answer. If the de Broglie wavelength of a particle of mass m is 100 times its velocity, then the wavelength value in terms of its mass and Planck's constant is what? Simple, it's not a big deal, okay. Shraddha, don't retract the message. Don't worry if you are wrong, it's not a big deal, okay. You might be wrong, but you are attempting. Okay, let's see. 30 seconds. (43 and 21). Okay, 20-second gap is there in the live and what I am seeing. Okay, 10, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. Now let's start. See, it is just saying it is a de Broglie wavelength of a particle. So this is lambda of a particle of mass m. So the particle's mass is also given, of mass m is equal to 100 times its velocity. So the lambda is having a value which is 100 times the velocity. Okay, lambda is equal to 100 times of v. Then the wavelength value in terms of the mass and the Planck's constant is. Can you tell me some relation? Can you tell me some relation between lambda, v, m and h? And that is lambda is equal to h by mv. Now see, velocity is equal to 100 times of this, lambda is equal to 100 times of velocity, right? So now let's see what we can do. We can just put it here. Instead of lambda we should put 100v. Why? Because it has said that the de Broglie wavelength of a particle of mass m is 100 times its velocity. So that's what we did. Now just put it here. Okay, take the v on the other side. If you take the v on the other side, we'll have 100 v square is equal to h by m. Now we have to get the answer in this form. So we have to get the velocity. Then the wavelength. We have to find the wavelength. Okay, so we have to find the wavelength. Wavelength value in terms of the mass and Planck's constant h is, let's see, okay, because wavelength and the velocity are equal somewhere. Okay, now 100 v square, you have to root it down. Now when you root it, okay, that is the answer. Wait, am I doing something wrong? Hey, no, it's not like this. Okay, mv, so we have to put in, we have to find lambda now. So we have to type in terms of lambda. Okay, now 100 lambda will go on that side. Lambda square equal to h by m. Now just take a root on both sides. Okay, so it is 10 lambda. So I'll write lambda here and take 10 on the other side, and you will be left with h by m. Okay, so this is the answer. Let's see which option is 1 by 10 h by m. 1 by 10 m by h by m. Okay, this is the answer. Got it? Option number 3. Let's see who has answered this. Wait. 10. Sorry. This is going to be 1 by 100. Okay. And 100 will be on that side. So this particular thing will be in divide. So it will be now multiplied. So not this option. It is this option. Got it? So let's see. Fifth, option 1. How did you got option 1? It's not option number 1 is not right answer. Option number 2 is right answer, Shraddha. Priya, you have not answered this question, try to answer it. Okay, got it? So this is the option, option number 2 is the right answer. Okay, now let's go on the next problem. Okay, 5th, and now this is the 6th. This one is easier. Okay, start this question. The correct set of 4 quantum numbers for the valence electrons of a rubidium atom Z equal to 37 is, tell me. Z is equal to 37. Rubidium atom Z is equal to 37. Okay, 12 seconds. 6th, somebody answer the question number 6. Okay, now done. Let's see what is the answer. The correct set of 4 quantum numbers for the valence electron of a rubidium atom. So first of all, we need to find where is that valence where is the valence electron of the rubidium atom lying. Okay, so can you tell me that electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p6, okay, and 4s2, 3d10, 3d10 and 4p6. Okay, let's see how many number of 10, 3s2, 3p6, 4s2, then again 10, again 10, okay, 4p6. Now 4p6, and then we have 4s2 is done, 3s2, 4s2, 5s2. 5s2 is there, right? Okay, see, it is 6, 10, 10, 10, 30, 6 is 36, we want 37. So for 37, only in the last electron, this valence electron will be in 5s1. Okay, so the valence electron is in 5s1. Can you easily tell now what is going to be the number? 5s1. Okay, see, 5, and 5 is the principal quantum number. Okay, so principal quantum number 5, 5, 5, 5. Okay, 3 options are there. Let's see. Okay, S, P, D, F. For S, the azimuthal quantum number is what? Tell me. For S, the azimuthal quantum number is 0. For this 1, for this 2, for this 3. Okay, so 5, 0. Got it? 5, 0. Okay, 5, 0. Okay, then 5, 0. No answer is 5, 0. It's not also 5, 0. Okay, got it? So this is the answer. Understandable? Option number 3 is the answer. Let's see who's writing. Okay, 6, option number 3. You are right. Priya, you are right. Good. And somebody else who is also watching, just try to answer. Okay. Let's go on to the next question. Okay, try to answer this question. It's very easy question, not much time. Okay. I have started timing. Let's see who is able to answer it first. Question number 7. Priya, Shraddha, try to answer. Okay, 4 people have joined. Let's see. Somebody who is joining right now, just write your name. Okay. Try to write your name and try to answer these questions. Six. Somebody just answer. Timer is set already. Okay. Try to do this question. 4, 3, 2, 1. Okay. We are done. Let's try to do this question. Now, identify the graph that correctly depicts the variation of momentum P and a de Broglie wavelength. In the previous question, I think it was previous, right? Lambda is equal to h by mv. Okay, what is mv? Mv is the momentum, so lambda is equal to h by p. Okay, so h is indirectly proportional to p. If you make a graph between it, you will see this type of relation. X is indirectly proportional to 1 by y, or y is indirectly proportional to 1 by x. This type of graph is actually a rectangular hyperbola. Okay, so option number 3 is going to be the answer. Option number 3. Okay, nobody has answered till now. I'm not seeing any answers. Okay, wait. No, wait. This is not option. P and lambda. Between P and lambda, it should be like this. Okay, between P and lambda. P and lambda, no. Lambda 1 by p, lambda. Okay, none of the options are like this. It means we have to find the relation between lambda and 1 by p, or lambda and 1. Okay, we need to find the relation between lambda and 1 by p, because none of the options. Otherwise, if lambda and p, if there is a graph between lambda, p or lambda or p is same, right? Then it should look like this. Otherwise, they have given these options, lambda and 1 by p. So we need to find the relationship between lambda and 1 by p. Okay, why I am writing h over here. So lambda 1 by p. So h is constant, so it is directly proportional to 1 by p, right? Lambda is directly proportional to 1 by p, remember. So when lambda is directly proportional to 1 by p, x is directly proportional to y. Okay, x is directly proportional to y, so it should be a straight graph. So option number 4 will be the right answer. So who has answered? Okay, nobody till now. Why? Is there any lag? Because nobody has answered. If there is any lag, let me know in the comment section if there is any lag. Okay, otherwise type no. Okay, let's start with the next question. For a subatomic particle, okay, the uncertainty in position is same as that of uncertainty in its momentum. It means delta x is equal to delta p. The least uncertainty in its velocity can be given as. So we need to find the least uncertainty. Least uncertainty. So let's see, somebody is answering. Hi. Why nobody answering? Is there any lag? Okay. Now let's start doing the question. Okay, it is saying that for a subatomic particle, the uncertainty in the position is same as that of the uncertainty in the momentum. So, okay, do you know this Heisenberg's uncertainty principle? Delta x dot delta same as that of uncertainty in its momentum. Okay, delta p is equal to h by 4 pi. Have you heard this question? No, it's not certainty. Wait. Delta x delta p is equal to h by 4 pi. Got it? Now, for subatomic, the uncertainty in the position is same as that of the uncertainty in its momentum. So delta x is equal to delta p. Okay, so delta x equal to delta p. Should I put this in terms of delta p? So it is again delta p dot delta p is equal to h by 4 pi. Got it? Now it means delta p whole square is equal to h by 4 pi. Got it? And now the square root. Okay, this side and this side also. So delta p is going to be delta p only. Delta p square is going to be delta p. Okay, which is equal to mv. Got it? And which is equal to root of h by 4 pi. It will be 2 will be outside and pi will be inside. Got it? Now I am going to take m on that side. So v is equal to root of h by pi. Okay, and 1 by 2m. I think this should be the answer. 1 by 2m h by pi, 1 by 2m h by pi, delta v. Option number 4 is the right answer. Okay, delta v 1 by 2m h by pi. Got it? So let's see if somebody has answered. Why somebody is not answering? Okay, 8 option number 3. Shraddha is saying 8 option number 3. No, you are not right. Okay. Okay, next time try to do well. Priya has answered 8 option number 4. You are right. Okay, good, Priya. let's go on to the next question. Okay, good. Now let's start the timer and see. Okay, so try to do this question. As the number of radial and angular nodes for 3p orbital is 1, 1 respectively. The number of radial and angular nodes depends only on the principal quantum number. Tell me, what is the number of radial? Okay, I'll tell you just for a hint. The number of radial node is n minus L minus 1. Number of angular node is equal to L. Tell me. 26 seconds are left. Question number 9, try to answer. Okay, I think 10, 9, 8, 7, 6. Priya, Shraddha, try to answer. Okay. Now, let's start. In our timer, we just want. See, always remember number of radial nodes, okay, is n minus L minus 1, okay, and number of angular nodes, okay, is L. So if you add them, so total number of nodes is how much? N minus 1. Got it? Now it is saying the number of radial and angular nodes for 3p orbital is 1, 1. Tell me, is that the answer? For 3p, n is equal to 1 and sp, so L is equal to 1. Okay, so it is asking number of radial and angular node. Let's get out 1 minus 1, 0 minus 1. Wait, n is equal to 1. Okay, good. If we find it, n is equal to 3. Okay, n is equal to 3 and L is equal to 1. Now, so 3 minus 1 is 2, minus 1 is 1 and L is equal to 1. Okay, assertion is right. Now, the reason is saying the number of radial and angular nodes depend only on the quantum. They don't depend on only on the principal quantum number. So, assertion is true. Assertion is true, but reason is not correct. The number of radial nodes, they depend on the principal quantum number and also this L. Okay, so it means reason assertion is correct, reason is wrong. So this option, third is the right answer. Okay, let's go on. Try to do this question. I'll set a timer. Okay. Which of the following conclusion could not be derived from Rutherford's alpha particle scattering experiment? I think it's easy, right? You should do it. 9, option number 3. Okay, let's see. Yes, 9th question, option number 3 was right. Priya Jyoti. Okay. There is a 20-second lag. That's why I am answering you after 20 seconds. Okay. Do this question. Okay. 10th, question number 10. Okay, 8, 7, 6, 5, 4, 3, 2, 1. Okay, now let's read the question. It is asking us which of the following conclusion could not be derived from the Rutherford alpha particle experiment. So we know they did an alpha particle experiment. Okay, so which conclusion? Okay, these are the conclusion, and which conclusion cannot be derived from that experiment. Okay, so most of the space in the atom is empty. Yes, we got to know about this thing, right? We got to know about how much space is there in the atom through this experiment. So this is not the answer. The radius of the atom is about 10 to the power minus 10, while that of the nucleus is 10 to the power minus 15. Yes, we also got to know about the density, okay, and also the radius. Electrons move in a circular path of fixed energy called orbit. This is not something which was told by this experiment. It was told by Bohr, okay. So this is not right. So it means this is the correct option. This is not the conclusion drawn from the experiment. Okay, so third is the right option. I think so. Option 1 is correct. No, option 1 is not correct. That is what is being told by. Okay, this conclusion is right. This conclusion is right. This conclusion is right. Okay, these three conclusions are drawn from Rutherford's experiment. But this conclusion was not given by this alpha particle scattering experiment. Okay, so because this conclusion was not given by this experiment, so that's why this is the answer. Okay, because it has asked what conclusions could not be derived. Okay, so this is a not type question. Now let's go to the next question. Okay, which of the following waves has? I think option number 1. Oh, okay, option number 1 is not correct. I already told you, right? Okay. Okay, so which of the following matters have shortest wavelength? Which of the following matters have the shortest wavelength? Electron, alpha particle, neutron, or proton? I think it's very easy. You guys can do it. So these are different electrons. Okay. Obviously, wavelength doesn't depend upon charge, so we don't need to care about charge. We need to care about the mass. Priya, try to answer. Okay. Okay. 8, 7, 6, 2, 1. Let's try to find the correct option. Okay. Which of the following matter waves have the shortest wavelength? Okay, so we know that the relation lambda is equal to h by mv. Okay, right? For the same velocities, and obviously h is a constant, we can say the lambda is indirectly proportional to m. Okay, so we want the shortest wavelength. It means the value of m should be highest, right? So which particle is the highest? Electron, alpha particle, neutron, or proton? Tell me. 11th, option number 2. Yes, alpha particle is right. Okay, this is the heaviest particle and lambda is going to be the lowest. So yes, you are right, Priya Jyoti. Okay, good. Let's go on to the next question. Question number 12 is in front of you. Okay. Okay, so question number 12. Which of the following statements about the electron is incorrect? Okay, it is negatively charged. Yes, the mass of electron is equal. It's very easy question. Don't need to give a time for this thing. Okay, it's very easy. We know that electron is negatively charged. That's it. Okay, the mass of electron is equal to the mass of neutron. Is that right thing? No, mass of protons and neutrons are equal, but the mass of electron is much lesser compared to the proton and neutron. Okay, so this is the incorrect thing. So which of the following statements about the electron is incorrect? So we wanted the incorrect thing. So second option is the incorrect statement. That's why it's a correct option. Got it? Let's go on to the next question directly. No need to waste time over these type of questions. Okay, here is the next question. Now let's start the timer. 1 minute. Okay, Gokul Arul, 12, option number 2. B. Naksh Davra. Welcome Naksh Davra. Okay, Gokul Arul, welcome guys. Okay, good to see you join. Okay, good. Option B. Naksh Davra, you are right. Priya, you are right. Gokul, you are right. The lowest value for the G orbital is? What can be the lowest value for G orbital? Think about this. What is the lowest value of G orbital? Welcome guys, welcome. Thirteenth, option number 2, Priya Jyoti answered. Option number 2, let's see, is it right or not? Okay, if somebody else is answering, try to answer. Gokul, Naksh. Okay. See how many orbitals we have. Okay, we have to name their quantum number. So S, P, D, F, G. S. Okay, azimuthal quantum number is 0, 1, 2, 3, 4. Okay, so this G is having a L value equal to 4. Okay, remember we are asked, it is asking us the lowest value. Okay, we know that the value of L, it can go from 0 to n minus 1, right? Okay, now it is G and G value is 4. Okay, and it means this number to be the lowest. Okay, we have to take this as the highest value of L. Got it? So now if we take 4, okay, as this number n minus 1, okay, and we take 1 on that side, it is n equal to 5. So if n was equal to 5, okay, then G will exist. Okay, have you heard, like for quantum number 1 only S exists, right? For quantum number principal quantum number 2, S and P both exist. 3, S, P, D, right? For 4, S, P, D and F, right? And similarly for option number principal quantum number 5, S, P, D, F, G. Got it? So 13, option number 2, Gokul, you are also right. Very good, Gokul. Okay, so option number 2, good. Let's go on to the next question. And somebody who's watching this recording, try to comment your name, guys. Okay, I want to see where are you from. Okay, next question. Okay, which of the number of orbitals indicated by the following set of numbers is n3, L2, m plus 2? Tell me the number of orbitals. Focus, you don't need to actually focus on this number, you just need to focus on the behavior of this number. Okay, the number of orbital indicated by the following set of quantum numbers. So how many orbitals we come, how do we actually classify these things? Okay, am I visible? Okay, first is shell, then subshell, then orbital. For telling shell, it's principal quantum number. Telling subshell, it's azimuthal quantum number. Then telling orbital, it's that magnetic quantum number. Okay, and then if you want to tell the spin, you can tell it. Okay, 13. Okay, somebody answer 14. Somebody try to answer 14. Time's over. It's very easy question. Okay, the question is, see, n is equal to 3 is okay, 3. L is equal to 2. It means what? S, P, D. Okay, D. Got it? Now, if M is fixed, okay, you do not know if it's X, Y, Y, Z. Okay, there are lot of X, Y, D, Y, Z, D, Z, X. Okay, sorry, X, Z, and D, X square minus Y square, and D, Z square. We don't know for which one M was equal to 2, but we know one of them is fixed. Okay, so we are trying to talk about one of the fixed orbital, not all these 4, because this number is a fixed thing. It must be talking about a single orbital. Okay, maybe just suppose Z square. Okay, got it? So it means it is talking about only single orbital. So option number 1 is the right option. Got it? So somebody has answered 14, option number 3. Okay, Priya Jyoti have answered option number 2. No, option number 2 is not correct. Okay, see, you must be confusing spin quantum number. Spin, okay, you got this thing. Now if I gave you, there are 2 spins, right? So 2 spin quantum numbers will be available for this thing. 1 plus half, another minus half. Got it? But not 2 orbitals. 2 spin quantum number can be there, but not 2 orbital. Okay, so 14, option 2, 40. Okay, this time nobody was right. Okay, now it means this was some question that will get you confused. Try to not repeat the mistakes. Okay, just know this question. Let's go on to the next question. I'll put it here. Okay, okay, try to do this question. The possible values of n, L and m for the electron present in 3D orbital would be respectively. It's very easy question. I think you can easily answer. Kanishka, okay, Kanishka, welcome, welcome Kanishka. I have seen you in the last class also. Okay, why are you late right now? The session has already started like around 45 minutes back. You have already missed 15 questions. Okay, try to write attempt those 15 questions by watching this recording. It's very easy, try to do it. Okay, we just need to find the possible values for 3D. Okay, it's literally visible in front of you. What is the answer? Okay, the possible values, we just need to find the possible values for 3D10. Let's take it 3D. Okay, 3D only. So this is n. We know for S is equal to 0, P is equal to 1 and D is equal to 2. Okay, I'm talking about azimuthal quantum number. Got it? And the magnetic quantum number goes from minus L to plus L. Okay, so it means minus 2, minus 1, 0, 1 and 2. So n is equal to 3, L is equal to 2 and this is the value of m. Okay, option number 3 is the right answer. Let's see who has given this answer. Okay, nobody. Okay, very good, nobody is answering. 15 guys, try to answer. Okay, these questions are the easy ones. Kanishka, you have retracted your message. I have seen you. Okay, retracting the message. Do not do this. I can notice you. Okay, start this question. Which of the following set of quantum number is possible? Okay, we just need to see which thing is possible and which one is not. It means most of them are impossible and one of them is possible. Okay, try to focus on not type questions. Sometimes it is asking not type questions. Okay, 47 views, average view duration to 30 seconds. Timer is set, right? Timer done. Okay, which of the following set of quantum number is possible? We just need to see. Can you really think n equal to 0, does it exist? No, it doesn't exist. Okay, it starts from 1, 2, 3, 4, 5. So this doesn't exist. So wrong. So can n equal to 1? Yes sir, you are right, n can be 1. So when n is equal to 1, the value of L can go from 0 to n minus 1. Okay, so n is 1. So 1 minus 1 is 0. So 0 to 0, it means just 0 is there. Okay, so the L can only be 0. Yes sir, L is 0. This one is correct. Now then what can be the value of m? m1 is equal to 0 and ms is equal to half. Yes, m1 can be 0 and ms can be half, minus half. So this is the right option. Okay, these are the good values. But now let's check why these two things are not correct. If n is equal to 1, the L value can only be 0. That's it, and it is giving you 1. That is not correct. This should be only 0. So this option is incorrect. If n is equal to 3, the value of L should go from 0, 1 and 2, but it is given 3. Wrong. Okay, so only option number 2 is correct. So who has answered? 16, option number 1. Oh no, Gokul, try to answer it correctly. 16, option 1 is not right answer. Just because it is 0, okay, it's 0, it will not exist. And 0 will not exist, okay. Anyways, try to do the next question. Don't be demotivated. Try to do the next question. Okay, here is the next question in front of you. And let me start the timer. Okay. The total number of electrons in an atom with the following quantum numbers will be. So n is equal to 4 and n is equal to 3. The value of n is 0, L is 0 and the value of ms is half, minus half. Tell me which one is the right answer. By the way, you can use one psychology in this question also. Question number 17. Try to write this answer. Concurrent viewers are 4. Okay, now let's start doing this question. Okay, sometimes most of the times what they do is they try to give repetitive answer 16 16. Okay, so most of the time the answers are among these repetitive ones, 1 or 3. One of them is going to be the correct answer. Okay, but now let's just check. Okay, remember to find number of electron. Okay, the total number of electrons in an atom with the following quantum number is, okay. Now remember, to find total number of electrons in a shell, there is a formula. Can you tell me the formula? The formula is 2n square. Okay, to find total number of electrons in an n shell. So n is equal to 4, 4 4 16, 16 to 32. Now in the shell 4, 32 electrons can be there, but we are only talking about those electrons which have negative spin. Got it? It means half of electron is going to be positive spin, half of electron is going to be negative spin. We are only talking about negative spin. So half electron will have positive spin. Okay, half electron will have negative spin. We are only talking about negative spin electrons, so it is total number of electron is 16. Okay, in case of n equal to 4, and if you want half minus half spin, then it should be 16. So which option? 16 16. See, I told you na, one of them can be the answer. Let's see if somebody has answered. Nobody has answered this question number 17 right now. Okay, now is it 2 or, okay, option number B, n is equal to 3 and L is equal to 0. Let's put n is equal to 3 means 3, got it, and L is equal to 0, it means here S. So 3s. So 3s is just a simple orbital and only will have 2 electrons, that's it. So 2. Okay, so option number 1 is the right option for question number 17. Okay, so 17, Kanishka has answered option number 3. Okay, Kanishka, no, actually this is 8. Okay, and 8 electrons cannot be there. Okay, because for 3 and L is equal to 0, it is 3s. Got it? So it is 3s, and in case of 3s orbital, only 2 electrons can be there. So for B it's 2, for A it's 16. Got it? It's very good, Kanishka, that you are trying. Okay. Wait. Don't try to attempt the question right now. Let me just adjust the values. Okay. (16) option number 4. Well, I don't remember if the 16 option number 4 is the right answer. 16 option 4. Kanishka, you are sending too much messages. 17 option number 3. Okay. Is the 17 option number 3? No, it's option number 1, Kanishka. Option number 1 is the right option for question number 17. Let's see for this question the graph that represents the variation of xi square, which is the probability of density of any electron. The distance r is given, the number of nodes it is asking. That's it. It's easy question. Four, 3, 2, 1. Okay. So the graph that represents the variation, that is, it is telling us the probability with respect to the radius. Okay. So this is the atom. So this is the atom, right? And the probability of electrons are found out like this. Okay, with respect to the radius, and this is the probability. So with the near to the atom, it is the probability is very high. At this point, the probability of finding the electron is 0. The rate increases and then decreases. Got it? Now, a node is a plane where the probability of finding the electron is 0. That is called node. And can you tell me at what point the probability becomes 0? At this point. Okay. So only 1. Understand it? The number of nodes as per the graph is 1, because only there is one point where the probability of the electron, where finding the probability of the electron is 0. Understandable? Next question. Little bit calculative question this time. Okay, wait. I'll give a little more time for this question. This is calculative, right? Then we can start. Okay. 18 option number 2. Yes, very good. Kanishka, you are right. 18 option number 2 is the right answer. Priya, you are also right. 18 option number 2 is also right. Okay. Now, question number 19. Okay. A golf has a mass is given, speed is given. Speed can be measured within accurate 2%. The uncertainty in the position is. Okay, good. So we have to find a value of delta V, okay, and h by 4 pi m, everything is given. Okay, try to do this question. It's little calculative, that's why I have given a little more time for this question. Okay, 38 seconds. I think you can get advantage in this question because you can see 1, 2, 3, 4 in all the questions, the numerical value 14.6, 14.6, 1.46, 1.46, they are kind of equal. So it means you don't have to just do a calculation, you just have to estimate these values. These values you have to estimate only. Okay. 19 option number 4. Okay, I got answer Gokul. Very good, very good. Option number 4 Gokul. Option number 4 is right. Gokul, I have got your message. Okay. Remember Gokul, there is just a 20-second lag. So if you write answer right now, I will see. I will answer after 20 seconds. Okay. Actually, I am just watching the answer and then saying you, but this message will reach you after 20 seconds. Just a lag in the uploading speed. Okay. Now let's do this question. See, a golf ball has a mass of 40 gram. Okay. If you convert this mass 40 gram into kg, it will be how much? Right. I think 0.04. Right. 40 gram. Amount of kg, and the speed is of 45 meter per second. Do we know the equation? Delta x is equal to delta x plus delta v is equal to h by 4 pi, right? Delta x dot delta v is equal to h by 4 pi, and delta x equal to h by 4 pi. Sorry, this is not v, this is p. Okay, 4 pi delta p. Instead of writing delta p, I am writing m into delta v. Okay, we know the value of h. 4 and pi are constant. We know the value of m. We should know the value of delta v. How do we know the value of delta v? It is asked, delta v is the error, amount of error in the velocity. So it is saying 2% error, okay, in this 45 meter per second of the velocity. So 2% error is how much? 0.02 into 45. This much is the error. Got it? In 45 meter per second, if there is 2% error, then you can calculate, okay, how much is the error. So 45 into 2 is around 90, right? Divided by 100, you will get the value of delta v, and if you put the value of delta v in this equation, okay, you will get this answer. Okay, you will get this answer. And if you don't want to calculate this answer, just calculate the power. Okay, just calculate the power, that's it. Okay, and just be little careful while calculating the power. Okay, see, if you get the power somewhere near to this, okay, this can also be the answer, so be very careful. Okay, be very careful. Option number 4 is the right answer if you try to calculate it. Kanishka, option number 19, 4. Okay, you are right, very good. Kanishka, good. Now let's go on to the next question. We are with the 19 question. Just bear with us, we have got to go with 10 questions more, excluding this one. So guys, do this question. So it is asking you the radius of the second Bohr orbit for a hydrogen atom is. So it is giving everything, and it is just asking you the radius for the second orbit, okay, for the hydrogen atom. Do you know the formula? 0.529 into n square by z. Point 529 into n square by z. If you remember that formula, it's very easy. Kanishka, Gokul, Priya, everybody try to answer. Okay, 2, 1, 0, done. So the formula for the radius is, if you know the formula for the radius, this question is very easy. Formula for the radius is 0.529 into n square by z. Okay, got it? Angstrom. Now n square, the radius of the second. Okay, second. So and the value of n is 2. 2 square, it is 4. The value of z is going to be 1 because it's a hydrogen atom. So 0.529. Okay, it's something 0.5 into 4 is nearly around 2. Okay, so whichever answer which is near to 2 is the right answer. Option number 2. Okay, in exams you don't need to actually calculate the answer. Okay, so 20 option number 2, Priya, you are right. Then Gokul, you are also right. Okay, 20 option number 2 is the right answer. So first is Priya, Gokul, you are second. Okay, good guys, keep going. We only have 30 questions, so don't worry. Okay, try not to leave the session in between. Do all the questions. Okay, correct sequence of increasing order of effective nuclear Z effective of sp, d and subshells. Okay, effective nuclear charge. How do you get effective nuclear charge? By the way, it's very easy. If you would have just studied, like, it's a learning question, it's not a solving question. So see, the lag is there. I'm showing time here, 45 seconds is 31. So that's why there is a 10 seconds, sometime 10 seconds, sometime 15-second gap is there. Okay. Okay, the lecture has gotten to be of 1 hour and 2 minutes. Anyways, it's fine. 21, I've got our first answer, 21, option number 2, SPD. Let's see if it's right or not. And let me just tell you, it's very easy. Remember, so more your shell is near to the nuclear, okay, nucleus. When it is more near to the nucleus, more is the effective charge, okay, because shielding effect is lesser. See, Z effective is equal to Z minus S. Okay, Z is the nuclear charge and S is the shielding effect. Okay, now shielding is happening more in the people, more in the orbitals which are away. Okay, so remember the correct sequence of the increasing order of effective nuclear charge. Effective nuclear charge is greater for S, then P, then D, then F. Got it? Understandable? Why? Because for shielding, F is the greatest and D, P and S. Got it or not? Okay, in case of F, shielding is much more. Okay, outer electrons are much more shielded from the inner electrons, from the charge itself. Okay, I hope it's understandable, right? 21, option number 2, Priya, you are second this time. Gokul, you are first this time. Very good. Keep going, Gokul. Okay. So orbitals among the following which has the highest energy? I think if you just know the formula to find the highest energy or to set the highest energy, you will get it. Question number 22, guys, do it. Option number 2, option 22, wait. Okay, you are answering 21, okay. Nobody has answered 22. Do it. What is the energy? How to find the energy? 4 people are there, only 2 are answering. Why? Who is the third one? Guys, try to answer. (22) we have got our first answer. 22, option number 2 from Gokul. Priya, try to answer. Time's up, just 9 seconds. Okay, done guys, and we know to find the total energy, listen here who didn't get it, To find total energy, okay, you need to just add n plus L. You have to check this value. Whose value n plus L is greater is the highest energy, okay. So see, n plus L. Now S, P, D, F, okay, it's 0, 1, 2, 3. I'm just writing, so no need to convert. 5 and D is 1, D is 2. 5 and 3 because F is 3. 6 plus 0 and 6 plus P, P is 1. 5, 6, 7, 8, 6, 7. This one is highest, so it will have the highest energy, got it? So always remember the concept is the n plus L value should be greatest, okay. It is actually directly proportional to the amount of energy possessed by the orbital, okay. So this time Gokul, you are the first and the only one to answer this question. Very good. So very good, Gokul. If you are getting any confusion in the question, you also let me know that confusion, okay. Okay, do this question. Out of electron and proton, which one will have the higher velocity to produce matter waves of the same wavelength? We need the same wavelength, okay. We have electrons and protons. We need to produce wavelengths which are same. Now, which one has to run with the higher velocity? Electron or proton? I am also watching my own live stream, okay. 31 seconds and 18 seconds, 10-second gap is there, guys, so don't get confused. Gokul, try to answer. Kanishka, Priya, Gokul, everybody. Sometimes I click wrong buttons, okay. We know lambda is equal to h by mv, right? Now, we want the velocity to be same for both the electron and proton. H is already same, got it? Sorry. We want the wavelength to be same. H is already same. It means if we take m on that side, so m is indirectly proportional to v. It means whoever has the highest velocity should have the lowest mass, or lower mass, higher velocity, okay. So it is asking us which one will have a higher velocity. To have a higher velocity, you should have a lower mass to keep the lambda same for both of them. So lambda should be, m should be lesser, okay, because v is higher, the value of v is higher, so m should be lesser. So which one has lesser mass? Obviously electron is having a lesser mass, okay. Proton, neutron nearly same mass, then electron very lesser mass compared to them, okay. So option number 1 is the right option. So 23, option number 3, both will have the same, no, both will not have the same velocity. Gokul, you are not right. Both will not have the same velocity. See, lambda equal to h by mv, right? We have to keep lambda same for them. So lambda is a constant, okay. H is also same for them. Now mv is only left, so m I take on the other side, so m and v are indirectly proportional. So if you increase the mass, you have to decrease the velocity to get the same wavelength, okay. So the mass is lesser, that's why we will have a higher velocity. I hope you get it, Gokul, okay. So we are reaching till the end of the session, okay. Priya Jyoti, have you left? 23, option number 1. Very good. Okay, Priya Jyoti have answered this. Priya Jyoti, 23, option number 1. First guy, first person. I'll set a timer. Gokul is the second person to answer this question, but he has answered wrongly, okay. Kanishka is the third person who has answered correctly, okay. So you are the second person who has corrected the better answer. In case of the hydrogen atom, which one of the following transition has released the maximum number of radiation, okay. Wait, this question is actually more calculative, but if you just understand the little concept now, it's not much calculative, but okay, I'll give just 1 minute and 30 seconds for this question. Guys, answer. This question, it looks very tempting for some other options rather than the right option. Let's see, guys, who's right. Gokul, try to answer. Kanishka, Priya. Okay, 30 seconds are left. 24, option number 1. Very good. Who's that one? Okay, Priya Jyoti, you have answered. Okay, Kanishka has answered first. 24, option number, you are first this time. Priya Jyoti, you are second. 24, option number 2. Got it? Okay, let's see. Just let the time up. Gokul, try to write your answer also. If somebody has seen this thing. Okay, I'll tell you, it is just more of a calculated type stuff. Okay, so if you do calculations, you will get to know this. By the way, see, n is equal to 2, n is equal to 1, infinity to 2, 7 to 3, infinity to 3. Now we just need to calculate some values. Okay, but I'll tell you itself. Okay, because I know what are the values. 24, option number 3. Now, if you see the amount of energies at every level, it goes something like this. I think first is 13.6, then it drops to 33.5, it drops to 1.5. Okay, consecutively for n is equal to 1, n is equal to 2, n is equal to 3. Okay, got it? Till, okay, these are negative energies, by the way, negative energy, and it goes to at infinite shell, it is 0 energy. Okay, so if you drop from infinite to 2, that gap is how much? Only 3.5. Okay, if you drop from infinite to 3, that is also only 1.5 positive. But if you drop from this point, okay, but if from this point to this point, 2 to 1, how much gap is there? Nearly 10 electron volt. Okay, so this is having the highest energy gap. In case of hydrogen atom, which of the following transits has released the maximum energy? Okay, we want maximum energy, so this will release the maximum energy. But if you don't know the problem, if you don't want the problem to be done this way, okay, see, energy will be directly proportional to 1 by n1 square minus 1 by n2 square. Okay, this is the formula, and whoever has this value as the highest will have the highest energy gap. Okay, got it? So calculate for all of them, you will find that for this particular scenario, the gap is the highest. Okay, so 24, option number 2. Priya Jyoti, you have answered option number 2. I don't think option number 2 is right. No, option number 2 is not right. Okay, you think from infinite to 2. Okay, if you see the energy shells are in the decreasing order of difference. Okay, it like this. So the first gap from 1 to 2 is the highest. Okay, then 2 to 3 is only 3.5. This is 30, this is 10. Got it? If you see, wait, I'll tell you. I want you to remember these values. Okay, it will be useful for further inspections. Okay, so 13.6 electron volt minus of is energy at n equal to 1. At n equal to 2, what is the energy? 3.5. Okay, somewhere near, I don't know the correct value, I just know the rough figures. And for this is n equal to 3. Try to remember these values, 3-4 values you remember. Okay, you would have seen in every chart book they will be giving this thing. Okay, 24, option number 2. Priya Jyoti, you are not right. Okay, if you see this gap and at n equal to infinite, it means at the infinite position obviously the energy will become 0. Okay, so if you go from infinite to 3, the gap, you need extra 1.5 energy. If you go from 7 to 3, okay, 7 to 3, obviously whatever the number is required, it is lesser than this 1.5. Okay, now go from infinite to 2. Infinite to 2, it is how much? 0 to 3.5, it means plus 3.5. But if you go from 2 to 1, you will see it is the energy required is 10.2 electron volt. Okay, and that is the highest energy change. Got it? That's why. Okay, Priya Jyoti, I hope you have got the answer. Okay, and I hope you have got what you are doing wrong. Okay, and wait, I think I have some calculation which I can show you. Wait, let me just show you the calculation. Okay, I'll show. Okay, you can see for n equal to 2 and 1, this is 10.2 electron volt. For infinity 2, it is 3.4, and for 7 to 3, it's 1.23. Okay, and for n is equal to 2, it must be lesser, I guess. Yeah, it is 1.5. See, nearly 1.5, nearly 3.5, lesser than 1.5, and 10.2. You can avoid all this thing just by remembering those numbers. Okay, remember 13.6, 3.5, nearly 1.5. And then you don't need to remember. Okay, I think the next one is nearly 0.7 as far as I remember. Okay, so how many nodal planes are there in 4dz square? I have told you one formula: number of radial planes and nodal planes, and number of total planes. Let's see if you are able to do this question or not. This one is a special question. Okay, tell me. Got it. Okay, how many nodal planes are present in dz square? Okay. I have not started a timer, right? Only 30 seconds I will give you for this question. Okay, how many nodal planes are present in 4dz square? Tell me. Question number 25. Option number 3. Okay, first answer is given by Gokul. 25 option number 2, Priya Jyoti. Okay, there is a reason I have called this question special. Okay, see, can you guys write down the formula that you guys are using? So how many nodal planes are there? I think radial plane is n minus l minus 1, right? And nodal plane is l. Got it? So L will give the value of the, what do you call it, nodal planes, right? So nodal planes, value of L, and what is the value of L here? S equal to 0, sir, P equal to 1, sir, D is equal to, sir, 2. So L is equal to 2. It means, sir, option number 2. Wait. So, sir, option number, this can be the answer, but no, you're wrong. See, there is a reason they have given this z square. Can you tell me how dz square orbital looks like? 25 option number 2. Kanishka is saying 25 option number 2. Still you guys are incorrect. Okay, you have used the right method, but you are incorrect. Why? See, I'll tell you one reason for it. If you see the orbitals, d orbitals, okay, there are 5 d orbitals: dxy, dyz, dzx, dx square minus y square. Okay, I think x square minus y square or xy. Okay, and then dz square. Now we have 5 orbitals. If you see, these 5 orbitals are going to look like this, some are going to look like this, some are going to look like this. Okay, these 4 orbitals, they look like 2 dumbbells which are crossed like this. Okay, but and nodal planes are what? Just a plane. Okay, so see, the orbitals are going to look like this. 25 option number 3, 25 option number 3, I am getting still. Okay, you guys are wrong in this question. See, nodal planes are what? A plane where a node can be formed. So if you draw a node like this, okay, there is a point where there can be 0 probability, right? Okay, that's how you find nodal plane. But if you find the shape of dz square, this is an exception, noted down. If you find the shape of this dz square, what is the shape? It looks something like this. Okay, and there is this. This is the shape of dz square. Okay, now you cannot pass a plane through it, okay, such that the plane doesn't intersect to any of the lobe. Okay, so that's why the nodal plane in this case is 0, and this is an exception, note it down. Okay, I hope you guys have got the answer. And in case of dz square, nodal planes do not exist. Okay, so the planes which exist are the conical planes. Okay, if you see a cone, if you make a cone, right, like this, none of this particular area will be touching this cone. So that's why conical planes exist in dz square. Remember, conical planes exist in dz square, and even though formula is showing the answer number is option number 2, still option number 4 is the right option, because no nodal planes can pass through it. This is the exception, note it down. If everyone has got the answer, type yes in the comment section. Oh sorry, I mean in the live chat, if somebody is watching the live chat. Okay, got it? I hope this is clear. So next question, guys. Oh, it's not the full question, wait. Yeah, timer, start. I think this one is an easy question, you can easily solve it. Gokul, you got it. Kanishka, Priya Jyoti, everybody, you got the answer, right? You got the concept? We are almost at the end of the session, guys. Okay, just bear with us. Okay, try to answer. Given below are two statements, assertion and reason, and you have to tell the answer. Line emission spectra are useful in the study of the electronic structure. Given below are two statements. Line emission spectra are useful in the study of electronic structure. Very good, good, you are right. Okay, now reason. Each element has a unique line spectrum. It is also correct. Electron density in each plane. Electron density. I'm not able to understand what you are saying, Priya. You have written electron density in each plane. Okay, try to write some explanation so that I get you. Okay, and yes, we have got our first answer from Gokul. Gokul is saying option number A is right. Yes, assertion is right and the reason is also right. Okay, line emission spectra are useful in the study of electronic structure. Yes, we get to understand the electronic structure by actually understanding the line emission. The emissions which are coming out, we have to understand their behavior. Okay, got it? And why? Reason is each element has a unique line emission spectrum. That's why we are able to study the atomic structure, okay, electronic structure by this line emission. Okay, so 1 is the right option. Priya Jyoti, you are also right. Second, you are right at the second option, second position. Okay. Again, we have got a assertion reason problem. Okay, I don't want a mark, I just want a timer. Guys, do this question. 27 number question, Priya, Gokul, guys try to do it. Kanishka, emitted radiation will fall in the visible range when an electron jumps from 4 to 2 in hydrogen atom. Balmer series radiation belongs to the visible range for hydrogen atoms only. Assertion reason, guys. Tell us, is the assertion and the reason correct or not? Priya, Gokul, guys try to answer. 19 seconds are left. So we have got our answer. 27 option number 1, 27 option number 1, 27 option number 1, 27 option number. This time Kanishka is first, Priya second, Gokul is third. Okay, and yes guys, you are right. And let me tell you, there are many series. Okay, Passion, bracket, P fund. What do you call? Lyman, Balmer, Passion, bracket, P fund. Okay, so if the electron falls at level 1, okay, from any level to level 1, okay, from any level, if it falls to level 1, okay, those series are called Lyman series, okay, those series of line are called Lyman series. And then if any level falls at level number 2, these are called Balmer series. Same way 3, 4, 5, okay, Lyman, Balmer, Preston, bracket, P1, okay, and then there are series are Humphrey series, okay. Now Balmer is the only series which is visible, got it, when it falls at 2. So is it falling at 2? Yes, it is going from 4 to 2. It falls at visible region, and obviously that lies in Balmer series, which is actually visible range. Understandable? So assertion is correct, and reason is also the correct explanation for the assertion. Okay, got it? Somebody is joining new, just try to answer this. And let's go on to the next question. We are only left with 3 questions. Okay. Okay, this question is little bigger. We need to give it a bit size. Okay. Timer starts, just little bit more time. So guys, try to answer. Gokul, Priya, Kanishka, try to do it. Match the list 1 with the list 2, okay. Which model is given by which person? Let's see guys, you will just get confused between Rutherford and the Bohr's model, okay. Okay, we have got our first answer, 28, option number 4. Kanishka has said option number 4, let's see. Somebody else guys, try to answer. Okay, done. Gokul is also answering 28 option number 4. Let's see if this is the right option or not. Okay. Now, see, photoelectric effect is always related to the work function. Okay. Got it. Thomson is always related to the resin, right? So D1 A fourth. D1 A fourth. No. A is third. Sorry. A third. D1. Okay. 3 or 4, one of can be the answer, okay. So BC, either second is B or second is C, okay. Let's see. Rutherford's model, and we are left with what? Principal quantum number and radioactive rays. So remember, you guys are telling 4th, but Thomas matches with 3rd. Thomas matches with 3rd. Yes, Thomas matches with 3rd, Priya. Good. Remember, because of Bohr's model, we are able to get to the principal quantum number, okay. Rutherford's model didn't give us that. Rutherford model didn't give us principal quantum number. Bohr's model gave it, okay. And if you study the nuclear physics, you will understand the radioactive rays are given by, this research is done by Rutherford, okay. So B is option number 2. So B is option number 2 and C is option number 4. So 3rd is the right answer, okay. This time nobody was correct, okay. Try to be correct the next time, okay. Remember, Bohr's model is given, because of Bohr's model we have principal quantum number, okay, got it. And Rutherford, it is related to radioactivity, okay. If you would have studied nuclear physics, you will get to know about this, okay. I hope it is understandable, Gokul and Kanishka, okay. And also Priya, is it understandable? So if it's understandable, let's move ahead. I think you guys got it right. Next time I'll make a PPT just to be better. Okay, let me see, is this question okay or okay, this is a calculating question. I'll give you just 30 seconds extra. Okay, good Priya, good Gokul, just try to answer this question. Question number 29. The threshold frequency for the metal is this. When the radiation of the frequency is this, the kinetic energy of the electron emitted is how much? I think you have read the formula, right? H mu equal to h mu naught plus half mv square. So kinetic energy is equal to h mu minus h mu naught. Both of the h mu and mu and mu naught are given. So Priya, I think you can do it. Gokul, Kanishka, you guys can do it. Okay, 20 seconds only. 29, we have got our first answer. 29, option number 1. Let's see if somebody else has answered. 29, option number 1. Is that right or wrong? Gokul, okay, Priya, Kanishka, try to answer this question. So now the question is very easy. Whatever the kinetic energy you have, it is equal to the h mu minus h mu naught. Okay, the energy that is required for the ejection and the energy that you give, the difference in them will be given as kinetic energy of the electron. Okay, so it is h mu minus mu naught. What is the value of mu? It is 10 to the power 15. 1 into 10 to the power 15. Wait, the threshold frequency for the metal is 6 into 10 to the power 14. Okay. Now good. Instead of writing it as 1 into 10 to the power 15, should I write it as 10 into 10 to the power 14? Okay, somebody has given. Kanishka has written 20 and option number 2. Very good, Kanishka, you are right. Okay, and 6 into 10 to the power 14. Okay, now 10 minus 6, because 10 to the power 14 you will take common. Okay, 6, 10 to the power 14 common. 10 minus 6 is 4. Okay, 10 minus 6 is 4. Yeah, 4. And then value of h 6.624 into 10 to the power minus 34 joule second. Okay, so multiply this value with this value. 6.624 into 4. How much is 6.624 into 4? I'll just calculate it. I am calculating with a calculator. You are not allowed to do it. Okay, 6.624 into 20. Into 4. Nearly 24 or 2.4 something. So 26.4. 26.4 into 10 to the power minus 34. I should write it at 10 to the power minus 33 and make the dot over here. So 2.64 into 10 to the power minus 33. Wait, am I doing something wrong? Why am I getting answer? Okay, I have to subtract this thing also, right? Okay, so 2.6 something and then 33 and plus 14 is nearly 19. Okay, so 2.65 and 10 to the power minus 19. 33 and 14. Okay, good. Yes. This is the right option. Option number 2. Let's see who has given option number 2 first. Kanishka is the first person to answer this question correctly. Okay guys, now we are at the last question for today. Okay. Now here is the last question in front of you guys. Mark. Oh, I don't want to mark. I just want to start a timer. A 50 watt bulb emits monochromatic. Okay, this is calculative question, just a little bit time, okay, extra for you. So last question of the day guys, try to do it and after this we will end the session. Okay, and anybody who has been with the whole session, try to write your name at the last. I want to see who was the last person. Okay, to be at this still point. Okay, a 50 watt bulb emits monochromatic light of wavelength this much. The number of photons emitted per second by the bulb is. Okay, it is talking about per second. Guys, try to answer. 1.5 in 10 to the power 20, 1.8 10 to the power 19, 1.1 10 to the power 19, 2.3 10 to the power 20. I think the lag has increased. Now the lag is 30-40 seconds because here I am setting a timer and here 40 seconds has passed. So whatever I will answer you and I will see it after 40-second gap, you will get the answer, okay, of your chat. 5, 4, 3, 2 and 1. Good. Okay. Let's understand this question. Okay. Now, a 50 watt bulb is there. What does it mean by 50 watt? It means that bulb is releasing 50 joules of energy per second. Okay. Got it? Emits monochromatic yellow light of the wavelength 0.6 micrometer. So lambda is 0.6 micrometer. 0.6 micrometer, it means 10 to the power minus 6, right? Now 0.6 into 10 to the power minus 6 meter, that is micrometer, right? So 6 into 10 to the power minus 7 meter. Okay, that is the value of lambda, and this is the energy released per second. It is asking the number of photons emitted per second. So per second, whatever the number of, suppose what is the value? E equal to h c by lambda, right? This is the energy for one electron. Suppose n number of electrons are releasing, so you multiply the energy of one electron by n, you get total energy. Okay, and the total energy is, for 1 second it is 50 joule, so that should be 50 joule. Got it? So 50 equal to n 50 lambda by sc. Okay, so you can write it as 50 lambda by sc, 50 lambda by sc. So n equal to 50 into lambda by h into c. Okay, if you find this value, we will get our answer. Lambda 6 into 10 to the power minus 7, okay, meter. Got it? And hc is 6.624 into 10 to the power minus 34, and c is 3 into 10 to the power 8. Solve this thing. Okay, 30 option number 4, 1%. Okay, Kanishka is the first one to answer 30 option number 4, and Priyajyoti, your second option, that the answer for this question is 30 option number 4. And by the way, if you solve this out, you will get the option number 4 as the right answer. Understandable? So we have come across the end of this particular DPP. Okay, and we will be taking more sessions. Okay, tomorrow we'll have the same, we'll have another live session. Okay, so whoever is staying, Kanishka, Priya, Gokul, so everybody, okay, thanks for staying in the session and solving the questions. And till then, just see ya, bye bye, have a nice day, and make sure you guys, if somebody is watching this recording, make sure you join the WhatsApp channel, okay, sorry, WhatsApp group, because that is where we are actually putting all the links. Okay, that's it guys, bye bye, take care, see ya, have a nice day.